Okay. So the plan today is to go over the test, then talk a lot about the quest questions, because this quest was kind of all over the place. Some of y'all were good, some of y'all were not quite as good. Overall, this test was not the highest scoring. The good news is y'all were all consistent, except for Michael. Y'all were all consistent. So if you thought you did badly, don't feel bad, because the person sitting next to you probably did just as badly on it. So that there was that saving grace.
I was trying to figure out who that was.
That's, yeah, those are Jerry and Edwards right there. Jerry and Edwards, yours is right there. All right, so let's start with number one. And this is all I wanted to do today. We're missing a couple of people in third block, so we're not going to do the new lesson. We'll just wait till tomorrow, and you can have the rest of the time today working on your quests or whatever else you need to work on. Okay, number one, the area of the first quadrant region bounded by the graph of y equals 1 over x, the line x equals 1 and x equals 5 is rotated around the y-axis. Okay, non-calculator. To give you a crude sketch of what's going on, 1 over x looks like this. Okay, there is technically another part over here, but it's irrelevant in this problem. X equals 1 and x equals 5. Is that right? Yeah. X equals 1, x equals 5. So there's our area, and we're going to rotate this around the y-axis. There are two ways to do this one. I'll be happy to show you both. I went with shell on this one. It was easier to set up. If you did, well, I'll show you both ways. Okay, I'm going to work it with shell and get the answer, and then I'll show you how it would have been set up if you were going with washer. Here's why I chose shell, because we're going around the y-axis. When I go around y, if I go with washer, I have to turn everything into y values. And I notice that if I'm thinking y values, this guy is going to be split into two regions. Okay? For this part, from 0 to whatever that is, you have this line on top and that line on bottom. For whatever this line is to that point, you would have the curve on top and the line on bottom. Let's see, figure out. This is 0. This right here, because that's 5, our function value was 1 over x, so this would be 1/5. And this is at 1, so this would be 1. Not really drawn to scale, but you get the idea. So if I'm going washer, this is how I'm going to set it up. You will have chunk number 1. Washer is, let's see, pi from 0 to 1/5. Top radius is 5, bottom radius is 1. Okay? That's big R, that's little r. Okay? Then we would need to add that to whatever happens as we go from 1/5 to 1. This time we've got this on top, and we need to turn this into y values, so we would write this as x equals 1 over y. I'll let you cross multiply and divide on that one. Top function is going to be 1 over y squared. Bottom function is still going to be 1 squared dy. Sorry, it should be dy. Okay, so here's the setup if you're going to do washer. Anybody have any questions on how we got that one going? Because the top and bottom changed, and again on this one, top and bottom really means right to left because we're doing y values. It changed. He was on top, he was on bottom, and then we switched over, and this curve was on top and that curve was on bottom. So you have to set it up as two different pieces. I'm not going to bother working that one. I'll let you play with that. I went shell on this. It is, but doable. Quite doable. That appears to be a natural log right now, but when you square it, it's not a natural log anymore, so it doesn't even, that's just a number, but 24, so the antiderivative would be 24y. That's no big deal. Here's how I would do shell. Leave it in terms of x, and do our formula, which is 2 pi from a to b, in this case 1 to 5, because I'm going to stay in x values. R, the radius is going to be x, whatever x value I'm at, and the height is just gonna be the function value. It doesn't change. The entire way here, that's on top. No, you choose this one or that one, okay? And if you clean this up, you get the antiderivative, 2 pi. Antiderivative from 1 to 5, that cancels and you just get 1 dx. The antiderivative of 1 is x from 1 to 5, so we're going to get 10 pi minus 2 pi, which is 8 pi. Which is exactly the answer you will get if you barrel through this. Won't be pretty, but you'll get there. This is what I mean by you don't need shell. In the AP test, they say you can do everything without shell, and you can, but man, does that make it easier if you have shell. Okay, any questions on that? Cool. Good. All right, number 2. Let R be the region in the first quadrant bounded by the x-axis and the curve 2x minus x squared. The volume on R is revolved around the x-axis. This is textbook. This one is straightforward. So let's see, number 2. The zone we are looking at is a parabola like that, meets at 0 and at 2. What is this? Y equals 2x minus x squared. And I got 0 and 2 by factoring out an x and just setting it equal to 0, okay? And since we are going around the x-axis, this one is disk because there is nothing missing from the inside. For those of you that get confused on when to use disk and when to use washer, just always use washer and say you have an inside radius of 0, okay? If you only have one formula in your brain to keep there, just use washer and do an inside radius of 0. So my volume is going to be pi 0 to 2 r squared. Pi r squared. Good. Let's see, antiderivative. That's going to be, before we can take an antiderivative, probably need to multiply that out. 4x squared minus 4x cubed plus x to the 4th dx pi, 3/4 thirds x cubed minus x to the 4th plus 1/5 x to the 5th from 0 to 2. Get kind of stuff here. All right, pi 2, 4, 8, 32 thirds. 16 minus 16 and 32 fifths minus 0 because of that right there. Okay, common denominator. By the way, my heart at this point would lead me towards A because I see this and this, which is going to give me a common denominator of 15. So unless something reduces, A is my, if I'm really pressed for time and I'm looking for an answer, I might stop at this point and say 15, but I'm not. All right, common denominator is going to be 15. So let's multiply everything by 15, or whatever we need. This gets a 5, so that's 150, 160. This we need to multiply by 15. 15 squared is 225, another 15, 240. And times 3 gives me 96. Okie dokie, let's see, that's going to be a positive 256 minus 240 gives me 16, so 16 pi over 15, which does not reduce. Look at how much time you waste on the actual arithmetic. The setup and the antiderivative are really not that bad, you just have to crunch through a whole lot of numbers to get there. All right, number 3, I tried to throw you a bone on, or a big hint. The total area bounded by the cubic x cubed minus x and the line y equals 3x is equal to. That zone, you have x cubed minus 3x. It's ugly, I'm sorry. Something like that. Okay. and then y equals 3x, does something like this. So what ends up happening is you get two zones that actually end up being symmetric. So you have two options. You either find the areas of each individual chunk, or if you notice that it was symmetric, find one blob and then double it, okay? I'm gonna choose the one blob doubled. This goes from 0 to, where do they meet? I wanna say 2, yeah, with -2 and 2. So here at -2, here at +2 is where they meet. So I'm going to choose to do this. I'm going to go from 0 to 2 and then double it because of the symmetry. If I go from 0 to 2, the thing on top is the line, and the thing on bottom is the curve, which is x cubed minus x. So there's the setup. Top function, if I'm doing the right half of it, top function line, bottom function that. By the way, if you just went from -2 to 2 and one thing on top and one thing on bottom, you get 0 as your answer because all the positive area and all the negative area would cancel each other out. But if you set it up as two pieces and did this side with the curve on top and the line on the bottom, you get the exact same answer for this one. So I will double 0 to 2. To clean that up, we get 4x minus x cubed dx. So 2, let's see, what is that? 2x squared minus 1/4 x to the 4th from 0 to 2. Ugly, I'm sorry. 2, 4, 8 minus 4 minus 4 minus 0 for a grand total of 4 times 2 is 8. Sure did that right. Yep. 8. I still think one of the hardest things is setting it up. Y'all are decent at taking antiderivatives. I thought that, I'm sorry. When we get to the free responses, you'll see why. Okay, any questions on Einstein oder drei? Alles gut? Prima. Number 4. All right. I think this one freaks some of y'all out because of the letter A, that they didn't actually give you a radius in there. It was a number. They just wanted it to kind of float, whatever they chose. The base of a solid is a circle of radius A. All right, number 4. Circle of radius A. So I'm just picturing circle of radius A, which means this is A, that's negative A, that's negative A, that's positive A. And the equation of that circle would be x squared plus y squared is equal to a squared. I'm probably going to need that. Right? Every cross section perpendicular to the x-axis, so we slice it this way, is going to be a square. Okay. So there's my figure. What's the volume of the solid? Okay, pretty straightforward. Here's what I'm going to need to do. I need to know the length. Since it's a cross-section problem, I need to know the area of that thing. It is a square, and for us, the area of a square is side squared. So the length of one side is what I need to figure out. Well, if we solve this for A, we're going to get, if we solve it for Y, we get Y is equal to plus or minus the square root of A squared minus X squared. And all I did was bring the X squared over and then take a square root. The top half of it is the positive and the bottom half of it is the negative. The length of that base, one side, is just going to be 2 of these, the top and the bottom together. So my area in terms of x is going to be 2 of these squared. And let's let that sink in. Top half being 1, bottom half being the other, top and the bottom there. So I have this 2, and that squares because the area of a square is length times width, or the same thing there. Which if we clean that up, this beautifully cancels, that becomes a 4, and the root cancels out, and you get a squared minus x squared. So the volume of the solid is going to be, I'll go ahead and pull the 4 outside. All right, you have options here. You know what, let's not do that just yet. I'm going to do this first. Okay, we need a starting point and a stopping point. 2 options again. Number 1, you can go from negative a to positive a, or because of the symmetry, you could go from 0 to a and double. Because I love 0 so much, I'm going to go from 0 to a and double it. Again, this would have also worked if you had had a negative a here to positive a without the 2. Let me clean it up once before we take an antiderivative. Pull that out. 0 to a of a squared minus x squared dx. Again, this is why it's so super important to have your d whatever. You got 2 variables floating around in here, an a and an x. All right? If you're not putting the d whatever, it's difficult to tell which of those is the variable and which one is just a constant. So x variable, a just a number. Alrighty, let's come on up here. Should be all the room I need. 8. Okay, antiderivative of x squared is going to be, dangnabbit, of a squared is a squared times x. Again, that's just a number, whatever it is, 3, 20, 8, whatever. So the antiderivative is going to be that x. This is going to be 1/3 x cubed. Then I'm going to go from 0 to a. All right, let's plug stuff in and see what happens. Okay, if I stick in a, I'm going to get a cubed. If I stick in a here, I'm going to get 1/3 a cubed. If I stick in 0 for x, I get 0. So I'm going to have 8 times. A cubed minus 1/3 a cubed is 2/3 a cubed, for a grand total of 16/3 a cubed. This is the exact same work you do when there's a number. I think it just freaks you out a little bit because there's a variable and not necessarily a straight up number for the problem. All right, number 5. Yeah, I kind of like your logic. C looked the messiest, so C obviously had to be the right answer. Not always. Got lucky
Yeah,
on
that
this
doesn't
one.
always work.
Got lucky on this one.
Well, see, I used a little more logic than that, and I at least like, you know,
Kind of.
I was.
All right, average value. Your formula for average value, in case you can't find it in your notes, 1 over b minus a, interval from a to b of whatever the f of x is. So in this problem, they've given me cosine as my f, and my interval is from pi thirds to pi twos. So 1 over pi twos minus pi thirds, okay, that's b minus a. Interval from pi thirds to pi twos of cosine x dx. You got a couple of things going on in this problem, some simple algebra and some calculus. Let's take care of the simple algebra. Over here, pi twos minus pi thirds, we need a common denominator, that's going to be 6. So we get 3 pi 6 minus 2 pi 6 for a grand total of 1 pi 6. 1 divided by pi 6 is going to be 6 over pi. Okay? reciprocate it because you're dividing it under 1. The antiderivative of cosine is sine. Do not get that confused with the derivative, which would have been negative sine. We're going to evaluate that from pi thirds to pi 2ths. All right, 6 over pi is going to hang out for a sec. Okay, sine of pi 2ths is 1. Sine of pi thirds is root of 3 over 2, I think. All right, now I'm starting to think to myself, looking at these answer choices, even if I don't want to clean it up, I need to have a root of 3 in there somewhere, and C is the only one that has that. If we truly wanted to clean this up, we would get a common denominator of 2. So I'd call this 2 over 2. That is going to give me 6 times 2 minus root of 3 over 2 pi. The 6 and the 2 cancel out, and I get 3. 2 minus root of 3 over pi. So that's how they're getting their answers, a lot of arithmetic. Whew, man, that was messy. Conceptually, that was pretty easy. Got my formula cold. Just got to do all the algebra and arithmetic. Okay. Everybody cool in the multiple guess, non-kakalaka? Good? All right, clear the board again. Y'all are the only ones I'm worried about. They can hit pause and rewind. Y'all good? Good, all right. Which brings us to free response. Number 1. Let R be the region between the graphs of y equals 1 plus sine of pi x and y equals x squared from x equals 0 to x equals 1. Okay? There's the setup. How many of y'all tried to graph this? Anybody try to do that? Did you actually get a graph that looked good? Was it right? You just got one that looked kind of right?
Oh, yeah, I do.
Okay. The part of this graph in question is going to look like this. You have x squared, which is going to do this. That was the easy one. Okay. And then you have sine of, okay, the 1 is going to move the sign up 1 unit, and the pi is actually going to shrink it down. It's going to squeeze the graph so that it does something. Let's say this is 1. It's going to do this. Okay, and again, there's more sine graph. It would actually come down and touch. That's a bad graph. I apologize. It's supposed to go up more. It would do this, come up, curve down, and you would have more graph that does that, and this graph would go back here. But this is the piece that we're looking at. And they do meet at 1. So there's a reason that I gave you these particular graphs and that interval, especially on a non-calculator question. It's going to work out beautifully. Okay, you didn't need to graph it necessarily. Here's why. If I ask myself, all right, is there a switchover? Is there a point where these two graphs change places? You know, if there was an area that I had to do in 2 pieces, you would have to set this equal to that. And I'll tell you, that's rough to do. If you're trying to do that by hand, it's impossible unless you can look at it and go, I think 0 works or something like that. 0 doesn't work, by the way, 1 does. So 1 is where they would meet each other at the point 1, 1. Yes, you got it. They met at 1, 1. A, find the area of R. You know what? I thought this was one of the easier ones, but man, did y'all butcher the antiderivative on this one. All right, area. Antiderivative from point A to point B, which in this case is 0 to 1. Top function, which is our sine, minus bottom function, which is our x squared. So we're going to have the sine function, 1 plus sine of pi x, minus bottom function, which is x squared. And really don't think we need that set of parentheses, but can't hurt. All right, let's rock and roll. This is the part I was most disappointed in. What's the antiderivative of 1? X. That's easy. I think only 2 people, maybe 3 out of both classes got this next part right. Sine of pi x.
Hey there.
First,
I
we're
knew
taking
it
an
was wrong.
antiderivative. The antiderivative of sine is negative cosine, okay? However, that was not x, so we're going to have to use a teeny tiny u sub. And you should be able to do this in your head, but if you let u be pi x, you get du equals pi dx, so we just need to bring over that pi. Okay, now notice, even though there's a big problem involved, I'm only using u sub on this little chunk right here. He is fine, I can do that in my sleep. So we should have had an extra 1 over pi in front of that. For those of you that got the cosine part of it, which a lot of you did, great. Not a lot of people got the 1 over pi. Okay, so be careful with that teeny tiny u sub. And then minus 1/3 x cubed from 0 to 1. Again, 0 and 1, 2 of the greatest numbers to plug into any function. Who doesn't love that? All right, let's stick in, by the way, 0 does not give you 0 in this example. If we stick in 1, we're going to get 1 minus. All right, here we go. Pi times 1 is pi. The cosine of pi is negative 1, so this ends up being plus 1 over pi. Stick in 1, you get minus 1/3. Minus, stick in 0. That's 0, and that's 0. That is not. If you stick in 0, the cosine of 0 is 1, so you get minus 1 over pi. Okay, whole number wise, I got a 1, not whole number, but not pi. 1 minus 1/3 is 2/3. 1 over pi plus another 1 over pi is 2 over pi. Common denominator is going to be 3 pi, so this is going to be 2 pi plus 6 over 3 pi. This would have been an acceptable way to stop right here. If you'd gotten to this point, you could have quit without putting your fractions together, that's fine. That's what it would look like if you stuck them together. Phew. That killed quite a few people. I was happy, a lot of you got this. I was happy with that. And then the antiderivative, you forgot the 1 over pi. That's the kind of u sub I'm talking about. Almost every example on the AP is going to have u sub, and that's the dinky little stuff that's going to kill you. Don't lose easy points like that. Part B. I love these kind of problems because you'll see it on calculator a lot when all you have to do is just type it and get an answer. They just want you to set it up and stop. All right, B. Set up, but do not integrate, an integral expression in terms of a single variable. So that just means make sure you have x's or y, just one variable, for the volume of the solid generated when r is revolved around the x-axis. Okay, so we need to take this and go around the x-axis. What kind of method are you thinking? Okay. All right. Really? That's interesting. Washer, very good. Pi r squared. We're going to go from 0 to 1. My outside radius is going to be the sine function. Okay, that's the farthest one. And my inside radius is going to be the square root. Relatively straightforward. So the sine thing, squared minus the other thing squared. And you can choose to doctor that up any way you want to, but if you write that down, that's full credit. Thanks for playing. Pi big R squared minus little r squared. C. Set up, but do not, okay, this time we're going around the y-axis. Okay. Whew. Again, two options. If you're a sadist, you're going to go with washer. Here's why. If I'm going to do y-axis and turn everything into y's, okay, I notice part of the time this graph is on top and this line is on bottom, right here. So that one honestly wouldn't be too bad. We'd go from 0 to 1 and put the root of y on top and 0 on the bottom. Here's where it gets icky. You got to find out what that split is, which means you'll need to solve that for y and then write it in two pieces. Okay, so you're using the same function twice, or maybe just do one piece of it and, no, we can't double it because that's not the same volume. Not the way I did it. I did it with shell because the top and the bottom are always the same with shell. 2 pi from 0 to 1. My radius is going to be x, whatever x value I'm at. And my height is going to be that. Right there, top minus bottom. So 1 plus sine pi x minus x squared dx. Most common mistake with shell, you'll seem to get the 2 pi, you forget your radius. The radius is not always x, but xe. The absolute most work in this problem should have come in part A with the antiderivative and all the arithmetic involved. Parts B and C should have been, B especially, if you didn't get B completely right, then shame, shame, shame. C I kind of get if you missed the radius, you forgot the 2 pi, but shell can be useful. Can be useful. All right, any questions on non-calculator? Then we move into calculator. All right. It's going to be difficult for me to put the calculator up here to show you what I'm doing, so I'm going to try and talk you through it as best I can and leave it up to you to plug this stuff in the calculator to get answers, hopefully. All right, so first one. The area of the first quadrant region bounded by the y-axis and the line y equals 4 minus x and the graph of y equals x minus cosine x is approximately. Okay. Gosh, what does that even look like? So let's see, y-axis. First quadrant, y-axis, 4 minus x, so that one's going to cut through like this. Okay, it's 4 minus x. That's 4, that's 4. And then you have x minus cosine x. I don't remember what that one looks like. I think if you stick in 0, you get negative.